Okay. Hello, everyone, and welcome to this workshop on AI standards, application, and interaction in assessments. My name is Simone Vazzoler, and here with me there is Dilara Gumusbas. We are both two AI technical specialists at BSI. And today we will be talking about the EU Artificial Intelligence Act, the AI standards, and how these two are linked when we are conducting AI assessment. We will also explore these two topics by using a practical application through an example case study, biometric case study. Now, as all of you should know, in recent years, AI advancements have skyrocketed, and everyone is talking about is discussing when AI system will match or even surpass human abilities. But with the speed of technological advancements, there is also an increasing level of risk. And if AI systems do not have a supporting governance to manage those risks appropriately, then they can cause significant harm to the user. So that AI can advance in a safe manner, we must identify those risks and work to mitigate them, so to ensure that AI will be used as a force for good. So, keeping that in mind, let's see at what we will cover in this workshop. First, we will look at some of the key articles of the EU AI Act, which deals with the key requirements for high-risk AI systems, their importance, and how they are taken into consideration when understanding compliance with the EU AI Act. Then we will give some definitions about state-of-the-art harmonization and presumption of conformity. And finally, we will explore the first 2 points by using an example biometric case study, and we will see how different parts of an assessment can be carried out using standards and how these standards align with the EU AI Act. The learning objective for this workshop are that by the end of this session, we should be able to describe key requirements of the EU AI Act, explain the concept of state-of-the-art, harmonization, and the presumption of conformity using standards, list some of the key essential standards that we consider when we conduct AI assessments, and apply the knowledge that we gained to use state-of-the-art to assess against articles of the EU AI Act. So let's start discussing the EU AI Act. And what is the EU AI Act? Essentially, this act sets forth a framework of legal requirements that must be adhered to for an AI product to be placed legally on the EU market. And this adherence ensures compliance, and the product will be permitted on the market. So what are these requirements, and why these requirements are important, and what is needed to be compliant? So let's start by looking at some of the key articles of the EU AI Act that form part of this governance framework. And we are going to look at 8 articles from the EU AI Act, which detail the requirements for high-risk AI systems. First, let's start with Article 9, which is about risk management systems. And risk management encompasses risk assessment, evaluation, mitigation, and control. And here the idea is to anticipate and reduce risk before it affects the end user. And this is important because it's about being proactive rather than reactive about safety. Next, we have Article 10, which is about data and data governance. And as all we should know, data is the cornerstone of any AI system. And here we are talking about the need of meticulous labeling, preprocessing, evaluation of the bias, and training, validation, and testing. Why this is important? Well, data quality dictates the model's quality. And this means that poor data practices can result in a model that is not only ineffective, but potentially harmful. Moving on, let's look at Article 11, which is about technical documentation. And like any other technology, AI systems require comprehensive documentation. And these include a clear statement of the intended purpose, the model's design, and the software that has been used to build the AI system. Moreover, ensuring process quality using the documentation is critical for meeting the EU standards. The last article for this slide is Article 12, which is on record keeping. And this involves the detailed recording of events, maintaining logs, and continuous post-market monitoring. Here, the goal is to maintain traceability and enable robust risk management. All these records are vital for accountability on the ongoing evaluation of AI product impact after its release. Let's move on to the last 4 articles that we are mentioning today. And we have Article 13, which is transparency and information to deployers. And this article ensures an environment of trust between the technology and its end user. In this case, transparency is critical, and it's about making the AI's intended purpose clear, providing accessible instruction for use, and also ensuring that the end user can understand and interpret the AI's function and outputs. Then we have Article 14, which is about human oversight, and here the core principle is control and safety. AI systems must always be designed to be under human oversight, and this ensures that no matter the autonomy of AI, the final decision-making power rests within a human who can understand and mitigate any risk to user safety. Next up in line, last but not least, next up we have Article 15, which is about accuracy, robustness, and cybersecurity. In this case, the EU AI Act requires that the model is accurate and robust against various conditions and potential cyber threats. And this involves incorporating privacy consideration from the start. And it's crucial because it directly impacts user trust. And people need to be confident that their data is secure and the AI's decisions are reliable and good. Finally, we have Article 17, which is on quality management systems, and ensuring ongoing compliance with the AI Act through continuous quality control and quality assurance processes. And the goal here is to have a systematic approach to maintain the standards set by the AI Act throughout all the life cycle of our AI system. Keep in mind that this article is the backbone that supports all the other compliance efforts. So, is there any question? Or can, yeah?
Just a question about the human oversight. How to ensure this, or implement this human oversight?
You have to build your system to be constantly under human oversight. That means that someone must control their output and eventually be able to turn off the system if it's going crazy. Okay.
How to control it, how to see this output? It's randomly or sample of outputs?
Sorry?
How this control will, sorry, thank you. How this control will be done? Is it on systematically on every output or a sample?
Depends on the application. So, yeah, it depends on your application. You can, through the post-market continuous monitoring, you can see if there is possibly data drift, something like that, that can impact the prediction, that tells you that your model is going wrong, that is going giving wrong predictions. And in that case, for high-risk system, AI systems, you need to turn off the system and then correct the behavior of the system.
Thank you.
So now that we have reviewed the main points of the UAI Act, now we ask the question, how can we check if these requirements are satisfied when we conduct the assessments? Okay, we can check that the AI systems are not only compliant with the UAI Act, but they also align with globally recognized standards, in particular those from the International Organization for Standardization, which is called ISO. And it is assumed that some of these AI standards will be harmonized with the Act. But what does the word harmonization mean? With standards harmonized against the Act, there is the presumption that if a particular standard is followed, then the corresponding article of the UAI Act will be satisfied. This means that if we adhere to harmonized ISO standards, it's possible to facilitate the presumption of conformity with the UAI Act, and this also simplifies the compliance process and reinforces the credibility of our AI system. The bottom line of this is that integrating ISO standards into our compliance checks, we are not just meeting EU requirements, we are aligning with international best practices, which can elevate the trustworthiness and the quality of our AI products globally. And these best practices are what we also call the state of the art. Okay, if we look at the ISO standards, we can find many ISO standards that are currently available, and more are being drafted as time goes on. And we know that we can use these ISO standards to check for compliance under the UAI Act, but which ones? The table on the screen details a few ISO standards on the right side. And you will notice also on the left column, there are 8 articles, the 8 articles that we mentioned before. Keep in mind that this is an inferred table, so there is nothing official, okay? And this table illustrates how the ISO standards corresponds to important UAI Act articles. As you can see, some of these ISO standards are prevalent in the table. For example, ISO 4213, which is assessment of machine learning classification performance, which focuses on evaluating machine learning AI system, is related to Article 10 on data and data governance, but also to Article 15 on accuracy, robustness, and cybersecurity. Another essential standard is ISO 24029-1, which is assessment of the robustness of neural networks, which is centered on the concept of robustness of an AI system. That is how to understand if your model behaves well under small input perturbations. And these standards, if you look, is again related to data and data governance, but also to Article 15, accuracy, robustness, and cybersecurity, and also to Article 17, which is on quality management system. And two more standards related to Article 10 on data and data governance are ISO standard 24027, which is bias in AI systems and AI-aided decision-making, which focuses on the detection and mitigation of possible bias when we build our data set for our AI systems. And the series of ISO standards 5259, which is about data quality and data quality for analytics and machine learning, which gives us some best practices on how to build a data process framework. Lastly, but not for importance, we mention a couple of standards on management systems, which are 42001, which is related to quality management systems, and also ISO 23894, which is guidance on risk management, which give best practices to manage risk. Now that we have learned a little bit about some of the UAI Act requirements for high-risk systems and how these ISO standards are related, let's apply our knowledge to a fictional biometric case study involving a product developed by a company X, and this product will be called Secure Record. Secure Record represents a cutting-edge approach to assessing electronic health records, and it's an AI-based software that employs biometric identification to secure patient-related data, including personally identifiable information. And by using facial recognition, doctors can access their patient's record without the need of a password, and those streamlining the workflow significantly. And at its core, this product utilizes convolutional neural networks to detect faces and recognize individuals from camera input. The technology main objective is to verify authorized access to EHR, enhancing security while maintaining user-friendliness. And Company X approached BSI to conduct a technical assessment of their product. And so here we have. Let's look at some of the findings during our assessment. While we were carrying out our assessment, we identified several potential issues in three particular areas of the product: the dataset, the model, and the documentation. Let's start from the dataset. Our evaluation revealed concerns about the dataset representativeness and potential biases. Specifically, it was collected from 300 individuals with a significant gender imbalance, 290 men to just 10 women. And this is important because it raises a big red flag around the possibility of building and train an unbiased model. Moreover, the data collection used only a single brand of camera, which could potentially introduce hardware-specific bias. And the dataset also lacked in diversity in samples per individual, and did not provide sufficient details about the poses or the demographic attributes of the data subjects, such as gender, race, or age. And this lack of details could severely limit the model's effectiveness across different real-world scenarios. Let's move to the model, where we noted that it was used a pre-trained convolutional neural network, and then it was fine-tuned on the collected dataset. In this case, they use accuracy as their primary evaluation metric. But we believe that additional metrics must be mentioned for a comprehensive assessment. And equally concerning is the documentation absence of adversarial attack testing or modeling. And this omission could indicate vulnerabilities in the model's robustness. And in our case, the system performance speed is average without details on what is acceptable in real-time usage. Moreover, false positive rates, which are crucial when we are dealing with personal identifiable information, are not discussed either. And given the privacy implication, this could be a serious oversight. Finally, in the documentation, post-market monitoring plans are not mentioned. And as we saw before, this is essential for ongoing compliance with the EU AI Act, as it ensures that your AI system will remain reliable and safe throughout its life cycle. So we have identified 5 critical issues that must be addressed to ensure compliance with the EU AI Act. And here are our 5 critical issues. And each one correlates to a different standard. First, the data might be imbalanced and biased. We know that there are a higher number of men than women. And this directly relates to ISO 24027, which again concerns with bias in AI system and AI-aided decision-making. Well, the adherence to the standards is crucial to create an impartial and fair model, AI model. Secondly, we question the diversity of the dataset. And the current state of the dataset may not be sufficient for robust performance of AI across various demographics. And this is critical per ISO 5259. Which is the standard dealing with data quality for analytics and machine learning. And again, a diverse data set is the backbone of a reliable AI system. Our third concern is that there is no evidence of testing for robustness or adversarial attacks. And this could be a significant oversight. And for this issue, we rely on ISO 24029, which focuses on neural networks robustness. And again, this is an important standard for ensuring the security and the reliability of AI systems, in particular the ones that are dealing with sensitive data. The fourth issue is that we are questioning if the accuracy is the right metric for this particular AI system. If you consider the potential impact of errors, in this case, we refer to ISO 4213, which is assessment of machine learning classification performance, to provide a comprehensive range of metrics to assess our model. And lastly, we noted the absence of post-market monitoring, and this is a compliance necessity and also a best practice, as highlighted by ISO 23894, which offer guidance on risk management. Continuous monitoring is vital to catch any potential issues once this AI system is in production and before it affects the end user. Let's now take a more in-depth look at every critical issues that we found, and for that I will leave the stage to my colleague Dilara. Thank you.
Question.
Thank you very much for the presentation. So my question is just about looking at the ISO standards and the EU AI Act articles, right? We can see, let's look at Article 9. We can see that we have like 3 standards, ISO standards. Does that mean that we have to like follow the 3 ISO standards or just one out of it?
First of all, this is not an official table, okay?
Yeah.
This is what we think could be the correspondence.
Okay.
Only after the harmonization process, you will know exactly which standards relate to that particular output. And it will officially be published by the EU Commission with the Act, so that you will need to comply with those ISO standards that they will publish to be compliant also with the EU AI Act. Okay?
So if they publish like maybe 3 standards to maybe one of the articles, does that mean that we have to like follow the 3 standards that they publish, or just one out of the standards will be sufficient?
Well, remember that a lot of standards have a lot of intersection. I mean,
Sure.
speak about the same things. Okay. In that case, you should follow all 3, probably because there are pieces that one standard do not cover while the other one covers. So, yeah.
Thank you very much. Thank you.
Okay.
Thank you. So just before starting the critical issue, I would like to mention a couple of points, which I won't go over, but I want you to know. So on the bottom part of each slide, you will see ISO standard, and then the mapping, EU AI Act article mapping. So, and then you will see also the sentence when I show the results after the next, after this slide. So every ISO standard and critical issue has minimum 2 pages. So you will see ISO mapping and EU AI Act article and directly the sentence. I won't go over them, but you can always refer it back. The second thing, there are some topics that are intersection actually, like you can see different standards and then they have same topic. So don't be surprised, which is very common. I try to make it here a little bit simple, so don't also think that, you know, but inside of bias maybe I have million type of different subtopics, so I will just go over the basic ones, okay? In any case, after the talk, if you have, you know, criticism, like, you know, you say like, add this one, so on, so we are fine with that, okay? This is just, you know, simple introduction, let's call it that way, it's very lightweight. So our first critical issue is data, imbalanced data and the bias, okay? And then we can address this critical issue, which ISO standard 24/027, which is bias in AI systems and AI-aided decision making. This standard includes topics that you can see on the screen: human factors, favoritism, indirect bias, fairness and balance, fairness metrics, and inherited bias. So let's have a look at each of them, like what actually it means. When we say human factor, we are talking about human, who collects the data, who deploy the model, those type of things. But for this case, I can say that more like who collects the data. So that is around human factor. When we say favoritism, we check whether AI model favors some specific group over other one. Like, for instance, maybe you heard about it, like maybe 4 years ago, I don't remember, there were a recruiting AI model that favors men over women for technical jobs. And you can understand from there, like what type of data that those systems are trained. And indirect bias is a bias that there are biases that are directly seen that we can understand from the imbalanced data, so on, but there are some vulnerabilities that we don't directly see. So I can give one example, for instance. Let's say we have a data set that is collected some particular area. I think US Census data set, maybe you are familiar with. They collect in some certain areas in Manhattan, so on. There are, let's say, students, particularly in some age groups, and then they are earning less money. And consider. If you have this type of data set, maybe you can say that I collected everything like young people, old people, but it's not correct actually. When you combine all of the features, actually there are some bias, but it's not directly visible. When we say fairness and balance and fairness metrics, we are more talking about like our data set is including a huge variety from everything. So for instance, it can be different ages, it can be different genders, it can be different races, so on. So we care about that. And fairness metrics is like, in case that we don't have those, at least we should have some sort of metrics out there to tell us, like, if I don't guarantee that way, at least I'm checking something. And inherited bias is something that I think all of us are very familiar with. Like, we are using a pre-trained model, we are using data set that is benchmark data set, but we don't know how it's actually collected most of the time. So inherited bias is coming from those. Overall, these are the basic topics under this standard, and according to you, our critical issue falls under which of them? So let's make it interactive as a beginning. So do you have any idea? Please shut them out. Like, just say it like, I don't know. Human factor can be there, indirect bias can be there. So let's hear from you. Anyone who wants to start? I assume that there are many data scientists, AI guys out there. So let me start, for instance. I can start with something very simple. So we talk about the data, right? Imbalanced data and biased data. I talk about the human factor that is on the heart of everything. So I think human factor should be there, maybe. Do you have any idea, like, what else it can be there? Okay, favoritism can be there as well, because we talk about, like, if it's favors, and there is some sort of potential favor, because men and women sample sizes are not same from the previous one. And then maybe this favoritism can cause maybe some fairness issues maybe. So let's have a look at the answers. Which three of them that you can see: the human factor, favoritism, and the fairness and the balance. So let's talk about it, like, why. When we say human factor, actually the human spans across everything, and especially in the data collection. So we are human beings, so we collect the data, and then when we are collecting, well, without knowing or sometimes knowing, we are biased. And then that is one of the factors that we need to care. And then for our case, it's imbalance and biased data sets. So human factor should be there. And when we talk about favoritism, so we talk about, like, we have a huge data set, like I think 29 men from 29, and then 10 women we use as a person. And then I will say 900 data from men, and then around 30 from women. So this may cause an imbalance. And those imbalances, like, for instance, when we train an AI model, which is biometric identification, we are superior, like, we really perform well, so on. But eventually, my system is not performing well. Maybe overall it's performing well, but it's not performing well over women, because it's not trained properly with the woman. So it doesn't understand directly to the woman the features that, the things. So with this case, what we call it is imbalance situation. And it's a problem, because not only it causes, like, favoritism that, men-related samples are, if the system sees a man, it performs well, but it also causes a little bit hidden issue, which is the fairness, because at the end of the day, my system saw a lot of men data, and then it's so natural, it's not like because it's the fault, but it's so natural for the system to see every input as a man. Like, because it recognizes the features related to men, so on, but it may cause a big problem for women at the end of the day. So that's why fairness and balance isn't there, and it's a favoritism related, like, imbalance can cause also this issue. So overall, when we talk about these things, it's not like we need this standard to be sure that, when we are checking the conformity assessment, that the data-related issues, like bias-related issues, are on the safe side. So let's have a look at the next one, which is our second critical issue, the dataset diversity. And we can address this issue with ISO 5259. By the way, this is a standard that has many, like 1, 2, 3, 4, so on. So I just mentioned 5259. and which is about data quality for analytics and machine learning. So we have again several topics that under this standard, which is human factor. Again, we come as an intersection: completeness, sensor element, time factor, and privacy user consent. So again, out of these topics, which one do you think our critical issue falls under? So do you have any idea, or should we just go with the answers and then just talk about it? Anyone? Which one? Well, we can think time factor, data set diversity. Yes, we can think about it. So let me maybe go over what actually they mean. Then, then we can see the answers. For instance, for this case, human factor, since we are talking about data quality, who collected the data, how those data is collected. It's about that. Completeness, when we say completeness, is it diverse enough? Is it collected for, considering everything? For instance, we are talking about biometric system, right? When we talk about biometric systems, I think we should consider every variation of the pictures. Let's say an image-based biometric systems, and then it directly gets images over my face recognition. So if it's only collected one, let's say one angle, it's not okay. So completeness should be there, like there should be some variances that, for the data quality point of view. When we say sensor element, for instance, we know that different cameras, even now, like old times, I mean, I don't want to make my age known, but like taking picture old times with a Nokia phones and now it's totally different, right? So sensor, the different machines, different sensors or different, the things, equipment that we are using to collect data can also cause some differences. So when we are selling a sensor element, we need to be sure also that that variety is in there. Unless there are some systems that maybe, those systems are not that much causing artifacts, so that's fine, but again, in general. And we have time factor. Time factor is something that when we are collecting a data, I think we need to understand is the time series data collection. Because if it's a time series data collection, there are things that when I'm collecting, I need to be sure. Like, let's say it's a standard sensor data. I need to be care about Nyquist frequency, those type of things. Like, I need to be sure that time related data collection things are there. And privacy, user consent, which we are talking about privacy all the time. But it's very important that, I'm using a data that I have the user consent. If user doesn't let me to use the data, it's not also okay from the data quality point of view also. Because at the end of the day, I need to get their consent as well when I'm collecting the data. So let's see answers for this critical issue. So you see two different colors. The first two of them are very easy for you to directly refer for the data set diversity, because we talk about completeness, which is the variance within the data set, and we talk about who is collecting the data. Again, it directly affects to the human factor. But also the last two colored one, which is like the sensor element and time factor, can be also relevant. Which, by the way, like for instance, we said about that if our problem is time series related, obviously time factor will be important. So let's talk them as a whole, and then, from there maybe we can just conclude. So when we say dataset diversity, so we talk about the biometric system, right? Let's say that I train this biometric system with huge amount of data, but like perfect amount of data for the deep learning models, for instance. But I always collected my data in the same setting. Let's say I always collected in the, when it was morning, sun was shining, I always collected my persons like, stay on the same angle, same lightning setting, same time of the day. Okay, perfect. I collected and I trained with this one, but what happens if I use that system when I'm using in the real time now, I ship the model, so on, with a setting that, a person is a little bit moving the face, like a little bit angle, lightning is not that bright, so on. So the system most probably struggle because it doesn't see, even though it solves a lot of data, even though it performs perfect because the collected data, also the test data, most probably everything is under the same setting. So it will be a problem, it will be a struggle, and then we will reach to a point that, for instance, for biometric identification system, that we won't recognize, and then we cannot use it the way that it's supposed to be used. And when we talk about, that's why the completeness is important. Every time when we are creating a data set, we need to be sure that we are including all of them. And when we talk about the sensor element and time factor, in here, time factor, let's talk about time factor. For instance, we have a biometric identification system. Okay, we collected the data really well, we added like diversity, the angles, the lighting, so on, everything is fine. And then let's say I ship the data, but I'm not retraining again. And the person can become old a little bit, right? Like the hair color can change, I don't know, like if it's a facial recognition, maybe some sort of, you can gain weight, so on. So, I mean, I'm not talking about the wrinkles, but wrinkles can be there too. So, for those cases, I still want to be sure that the system should work without any issue. So, that's why for those cases also, we can say that it's important. Sensor element is also correct that, if we are shipping our, model for different places that images are taken, and then, artifacts related things that we need to think. So overall, so we talk about like the previously, let's have a look just to remember. We talk about like the bias, right? And we talk about the data quality, and then we understood that everything about these two things are affecting directly to the robustness of our system. So let's have a look at the next one, which if before starting, maybe we can talk about this. So this critical issue is about robustness and the adversarial attacks, but previously we discussed about like the data quality, so on, right? If I created a data set that everything is perfect, I get different angles. So all of the things that I said was related to robustness. Why I'm still not guaranteeing the robustness, but it means there should be some other elements that can contribute to the robustness. So for our critical issue, third critical issue, which is the no evidence that we couldn't find about robustness and adversarial attacks, and how we can address this critical issue with the ISO 24029, which is assessment of the robustness and neural networks. So let's see the topics that this ISO standard has, which are input perturbations, adversarial attacks, and consistency performance over time. So out of these ones, I want to mention a little bit, I will pass a little bit past, input perturbations. So we are talking about when we change a little bit the input data, and then directly put it to the system, how output change. So this is also important for our case, for the robustness. And adversarial attacks is something that if I do some attacks and I can bypass the system, because it's also important. At the end of the day, you want to ship your model without any problem, right? So let's have a look at the answers. So the answers are for this case, because the name suggests also like robustness and adversarial attacks. So let's go into deep a little bit, like what actually means. So we couldn't find for this case that there is no testing for robustness and adversarial attacks. And for biometric models, why it's important? So if we don't have these type of perturbations within the training, adversarial training, by the way, let's talk about it. So we have a clean data set. Let's say I have perfect clean data set without any issue, so on, like perfect resolutions, zero noise. I train the system with that one. But reality is not like this. For instance, I may use that biometric system under rain. So there will be some blurred maybe over the camera, right? So anything can happen, but still I want that robustness within the system. So consider that there are ways that, in this case, for instance, they didn't have the adversarial testing. And to manage this one, we can add some perturbations to the input data, and we can add them on the training. So, for instance, I have really clean-cut data set, but then I use these perturbations that you can see on the screen, a little bit rotation, a little bit adding some noise, so on, and I put those images to the training as well, to be sure that, I'm still consistent, I can be still robust enough. This is the adversarial training. In case that you don't have, in your, let's say you created a system, you think that your data set is enough, and you don't want to do any adversarial training, at least I need to see some proof that, you use these, for instance, these, perturbations like rotating, so on, and then you directly test it. And then your system still works fine, it's also okay, but there should be some sort of proof that, it's robust enough. So, but then we talk about like adding these ones as adversarial testing, right? But consider like this. So why we are avoiding them? Why we are avoiding adversarial testing? At the end of the day, I have a clean data. If I train really well, my model will work okay. Maybe for some perturbations, no. But let's say I use a lot of them, these input perturbations, and I mix with the clean-cut data. And when I train it, when I'm testing it, most probably my accuracy will fall down. Is it correct? Because I'm using a lot of perturbations. So at the end of the day, the model needs to understand and update the weights, right? At the end of the day. So then it's a delicate balance game that we need to be sure that we are using these input perturbations when we are doing adversarial training enough. But not too much, then we need to understand that, our accuracy is not falling down that much. So it's a really delicate balance game that you really need to know your data set, you really need to know what do you need, so on, from your model. And then let's check the second one, which we talk about like adversarial attacks, and then, there is no evidence about that. So why this is important? We talk about the biometric identification system. And unfortunately, algorithms are very nice, like we know that AI development is amazing, so on, but have a look at the pictures, and please also, if you want to read the paper, you can read the paper, but only the, on the top first pictures, like, the persons directly facing without any angle to the camera, and then the on the right side, the first picture that just print out image, the fake image, and then directly putting to the camera. So in biometric systems, maybe this is not a problem for a standard object recognition, so on, but it's a big problem for biometric identification systems, because unfortunately, if they don't have some extra models to avoid this fake image, because liveness detection is, for instance, in biometric systems are used as an extra. If they don't have, the second image will just bypass the system, and then maybe I am not that person, but I know that person image, and I use that image, and I enter to the system. So it will be risky. That's why it's crucial for our case, it's biometric identification, but also for many cases, like if we are talking about the security and we are using biometric systems, we need to be sure also in that. At least they should have some sort of extra modeling or some alignment that they should test these ones. If we don't see, we need to also find it as a critical issue. So as you can see, before starting this one, like we talk about the data set quality, we talk about, it's related to robustness, but then another things just pop up, like, another things which are these ones, input perturbations and adversarial attacks. So the robustness is a big issue, and that it's like 3D. You need to see the things 3D, not only one face. So let's have a look at the fourth critical issue, which is, okay, these are very easy ones, like is accuracy is the right metric. I'm sure that everyone is familiar with, like, every model, every problem, whatever you have as a data or the model, you need to understand the right metric, right? Like everything has a right metric, so if you don't use the right metric, even though you say that I am like superior with this one, we should judge, because we need to be sure that it's really the correct one. So for those cases, we talk about the imbalanced data set, right? And then a system that is trained by the imbalanced data set. So how accuracy can be the right metric? It cannot be. So that's why, these are the, by the way, I directly answered the question, but the question, critical issue directly suggests to the one. So let's have a look at the ISO standard 4213, which is assessment of the machine learning classification performance, and why we, when we have this critical issue, and why we can address with this standard. Because this standard has four main topics. Human factor, as we said, it's always there, like, who deployed the model, how the model is deployed, so on. Overfitting issue and real-time performance are also important for these cases, because it's classification performances are not always time-dependent, but there are some problems that requires real-time performance. Like it should be very fast. It should react when we are in the inference. It should really react fast. I will give one example. Maybe for biometric system, doctor is using, let's say, immediately, he or she needs a document that is related to the, some urgent matter. So it needs to directly enter to the system, that's why. And overfitting issue is something that I mean, we are talking about the performance, but this performance should be also generalized, right? Like if we are just using the data and the overfitting issue is, I mean, this is one of the topic, let's say. But for this critical case, which is accuracy is the right metric, as you can directly see, the first one, which is evaluation metric correctness. So for this case, as we discuss about it, like let's talk about like this. So we have a biometric identification model. And as we mentioned, like, you know, it's trained with the different different unbalanced data set. And then for unbalanced data set, let's say we will have a true positive and the false positives, which will directly affect to the, you know, I mean, correctness. So what we need to care about this is not the accuracy, but the correctness. I mean, I don't need to go over again and again. Okay. The fifth critical issue is on the documentation, they didn't mention about the post-market monitoring. Okay, so this is our fifth critical issue, and then we can directly address this issue with ISO 23894, which is the guidance on the risk management. So these are the topics about this standard, which is unauthorized use, which we need to be sure that, you know, what type of protection mechanisms that we are using. The second one is monitoring post-market surveillance, which name suggests that, you know, when we manage our modeling, like, you know, data collection, like we did every test until now, and then we need to be also controlling that, you know, if everything is going well. So this is all about that. Misconfiguration is something that we need to be sure that we are giving the right, like this is more like identity management system, so on. We are giving the right to the right persons. Like for instance, if it's a doctor, maybe it should see some patient-related information, let's say, within this biometric system. But we need to be sure that we are giving to the right doctor. And insider threats, this is something about like, let's say, this is a software, let's say it has been used by different people. We need to be sure that, you know, we have some protection system like anomaly detection, for instance, that has been used. And cybersecurity attacks, again, we have, I don't know, like it can be antivirus, it can be anything that has been used. But for this case, our critical issue, as name suggests, it's just unauthorized use. Monitoring and post-market surveillance, which directly the name suggests, and why it's important. So we need to understand that, you know, when we ship to the model, okay, everything is fine, but robustness, so on, we check every element, but things can change by the timing. For instance, for this case, data drift can happen. We talk about the aging, let's say, right? We talk about different issues, like, for instance, maybe not aging, but let's talk about the sensor, for instance. I'm using within a system that, let's say, my data is perfect, aging-related information is in there, data is very variant, that every lightning setting, so on in there. But I should be also guaranteeing that, let's say, from the sensor point of view, that sensor should work 2 years later, again the same. But it may fail, right? So I need to check still what's going on within the data and the model, how it reacts. And then I can guarantee that, you know, everything is going well. So that's why this is another important thing that we are checking in the conformity assessment. So overall, we try to describe the key requirements of the EU AI Act, which Simone mentioned, and then we try to explain the state of art and harmonization and pre-assumption of conformity using standards. So the standards that we gave, just the baseline, so it's not like the full standards that when we are checking something we are using, but it's a sort of baseline for us to understand. And we list all of the case standards that the sort of abstraction considered when conducting AI assessments. And last, we just apply our knowledge gained to use SOTA to assess against article of EU AI Act. So that was the end of the slides. I don't know if you have any questions. Yeah. Let's start from the... Yeah.
So thank you both for the enlightening talk. And I was wondering, because there is, of course, a difference between what the Artificial Intelligence Act is asking and what the current industry standards are. So I know that you are still in the process of waiting for those standards to arrive, but maybe from your own assessment, what would be, for instance, for the use case that you now mentioned, what are like the gaps between the like the regulation or the standards that are currently there and the major differences that the EU AI Act is going to bring?
Okay. Major differences, second one, like?
So, for instance, I mean, one of the major rulings is that now fundamental human rights will be included and environmental impact. So, for instance, have you looked at, for instance, what sort of fundamental human rights are at danger? Because, for instance, if you look at bias, bias and discrimination are sort of sisters in a way, like they live close together. They are part of the same sort of realm of problems. But of course, anti-discrimination is a individual human right. So it can be for one case already that if it's discriminatory, then it's a problem, for instance. So that is something that you don't calculate over the whole global model. So have you looked at maybe the sort of gaps right now, or maybe started thinking about it, or like, how do you see that?
Do you want to answer?
Well, actually, there are many gaps. Without taking into consideration, for example, bias or related stuff. For example, the UA Act talk about generative AI, and there are no current standards on generative, for example, LLMs, how to assess, how to build a good LLM, for example. There is no ISO standard for that. You must take into consideration that the industry is evolving very quickly and rapidly, and regulation and standards are always trying to catch the industry, but they are always behind. The standards cannot be too specific in general and cannot address directly one problem or one particular one particular problem, one particular task, because otherwise they will be solving only that problem. They, in general, will give you a framework to build your model in the best way possible. That's why we are talking about state of the art. But it's true that there are many gaps around many topics that we should catch up at least.
Yeah, but we still ask questions. Like, for instance, there is a freedom, like freedom in a sense that, for instance, EU AI Act already mentions topics, but doesn't directly says that, check this, check that, so on. Because it's not okay, you cannot do. The problem is there. Every problem has its own unique, questions as well. There are some baseline, like, when we say bias, data set diversity, we always ask same thing. But there are extra things, like, for instance, if it's time series related things, I can create even a bunch of problems in everywhere, like the modeling part, everything. So I think we ask generally now, at this stage, many things, because we need to be sure at the end of the day, it will be you, it will be me that is using those products, when they are available. So, and especially when they are, when there is a risk-related component, which is like, if they are risky, you need to check even more. So what we do is like we follow all of the things that we mention in here as a baseline, but we add, like, for instance, we talk about liveliness detection. You need to know, not necessarily you need to be data subject matter expert, but we have freedom to ask. That's the whole situation about conformity assessment. We follow standards, but we behave like we really don't know anything. We don't assume anything until we ask to you and then you answer to us. So I think this is something. For the LLM part, for instance, the gaps, 2 years we are developing like crazy in the AI field. Every day we see different papers, right? Like different research groups are publishing something. Today something is problematic. Tomorrow they solve it, another problematic thing come up. So what we do is also, apart from the conformity assessment, we also align with what is ongoing. We need to be sure that, if it's really right. Like, it's not like someone wrote in their documentation that this is the state of art. We also responsible to check, and then, if we know that there is something different, we ask. as a question and we refer directly. So I think at the end of the day, the gaps are, will be always there because it's always growing, right? But it's all about the risk management for today, what we know, and then we go from there. I think that's all. Thank you.
The presentation. I would like to ask if you know how many certification bodies have been accredited with the new ISO for the artificial intelligence. Any idea?
Sorry, how many?
How many certification bodies have been accredited?
I have no idea.
No
Probably
idea.
Maybe we can, Daniela, do you want to?
So at the moment, and maybe you are the best person to reply to this question, I would say, but so certification bodies can build their own certification schemes and issue certificates under accreditation or not. At the moment, the main focus is probably on 42001, I would say, which is the AI management system standard. But the standard detailing the requirements for certification body is not finalized and published yet. So I would say accreditation bodies are getting ready to accredit certification body to issue 42001 certificates. So probably is good to look at that standard at the international, 42001 and start building the quality management system of your company according to that standard, unless you have already a quality management system under other regulations.
We have an integrated management systems because we have been certified with 9,000, 20,000, 27,000. And I was wondering as well, when the time comes to be certified for the new standard, whether it can be integrated or it should be separated due to the complexity and the criticality that it has.
Okay, the AI Act is pretty clear on that. So the AI quality management system requirements can be integrated in the existing quality management system standards. There are some specificities you want to be looking at in terms of data governance and the fact that, an AI software has something different from a common software. But definitely the AI Act and the European Commission is looking to not duplicate efforts, either from conformity assessment side, but also from the provider side. So one quality management system, one risk management, one declaration of conformity, one CE marking. So you'll have to look at the extra requirements in the AI Act. Article 17 is the one detailing the requirements on quality management system.
I expect that we would become lead auditors soon for this standard.
Well, I can answer from BSI side, the British Standard Institution. We started building the AI team a couple of years ago. And accreditation body are getting ready as well. So, if you want to come.
So just to carry on that bit, as well as mentioned earlier, the standards are still being written, and for accreditation to be offered to certification bodies, the competence requirements have to be defined. That standard's currently being drafted. So the work, exactly the same as certification bodies, national accreditation bodies all over the world are working to try and dovetail with the publication of the supporting standard, so that we'll be ready as quickly as we can to support all our certification bodies, but that work's ongoing.
Okay. Thank you. Well, if there is a question, we can take it after, because I think we should let those guys to have lunch as well, right? So thank you very much for listening and coming.